Hey guys, Tech Agent, we're back with more 3D printing videos. It's been a while since I've done one of these, it's been about 2 or 3 months now, and that's for a good reason. My printer is almost always occupied doing stuff, and I just don't get the time to print out cool shit. I think you guys are Barnacules for the cool shit, so I don't want to step on Barnacules' toes. But anyway, it's been a while since I've done a 3D printing videos, and this month was the 6th month of ownership, of the Ultimaker 2, and I've done a lot of things with it. The Ultimaker is one of the best 3D printers out there, but even the best 3D printer requires some fixes, some tweaks to be one of the most efficient systems out there. I still believe 3D printers are not yet ready for being a consumer product. It's more of a prosumer thing. I mean, you need to really spend a lot of time getting it right and making it your exact specification, and that's why 3D printing will will need a few years until you can really go out and buy a 3D printer, and it shouldn't be a problem. But still, a lot of things need to be done to make it an efficient system. And over these few months, I've done a lot of tweaks, a lot of things with my Ultimaker to make it a completely autonomous system in which I can completely rely on it, and I know prints will not fail. So let's talk about those upgrades and the things I've done with the Ultimaker 2. Okay, so it's been a while since you guys have seen the upgraded, the 3D printing space. A lot of things have been done. So the first thing I want to talk about is this guy. Now, usually, your printers, the filament is right there, as you can see, and you feed the filament through the back and everything is fine. But sometimes, if you want to release some stress on the feeder, you can also mount your filament onto the side. So you're feeding it from this side, and you can also feed that from that side as well. This side is more preferable because there is less stress on it. But it's just one of the different ways you can print. Also, you can do one thing is that you can put an exotic filament, like I've got semi-flex right there. So I can put semi-flex right there, and I can have ABS at the back. Now I currently have PLA and ABS, but you can do anything. There is also another thing, you can put another filament at the bottom, so you can have 3 filaments. You can always swap out easily. That's nylon right there, so you can have these filaments always ready. You don't have to go at the back and just remove the filament from the spool holder and put a new one. You can just swap them out easily from anywhere. So that's one of the biggest things I've done. I've just added this spool holder, you can say, for this side. So it's pretty simple, and it works pretty good. So that's the first I'm just going to say upgrade that really has changed the entire dynamic of printing, because it really makes a huge difference, because when you can swap out filaments so fast, it's quite amazing. Now, the second thing before I twist this printer, I want to show you guys is the hot end. Okay. Now, as you guys can see, it's a bit of a different hot end. I've got a new fan shroud. I'll link this in the description. But this fan shroud, it's quite amazing actually. Now I actually put a new block inside. It's called the Olsson block. The Olsson block, basically is a new block, a new hot end for the Ultimaker. Now the Ultimaker 2 Plus comes standard with it, but the Ultimaker 2 did not have that. So you only had one fixed nozzle that was 0.4 mm. Now with the Olsson block, you can add almost any E3D M3 nozzle. So you can add any other M3 nozzle from E3D, from Ultimaker, from 3D Vextron or something. I forgot the name. Now the Ultimaker is capable for some amazing resolution, which you can even expand and even exploit with these nozzles. So here, for example, I'm just going to show you a couple of nozzles. There, as you can see at the top, I have a 0.6. Then I've got a stainless steel toughened nozzle for exotic filaments and abrasive filaments like copper filled PLA or what have you, in wood filled PLA. Any other abrasive materials you want to use, you have to use a stainless steel nozzle. You can also use a stainless steel nozzle for FDA approved filament, but that's a completely different story, and there's a lot to it, so I don't want to go into that. Then, as you can see, I've got a 0.25, I've got a 0.4, I've got a that's a 0.8, sorry, that's a 0.6, that's a 0.8 for I usually use the 0.8 for NinjaFlex. Then we have this guy. I think this is another point. This is a 0.2. No, yeah, this is a 0.2 and another extra one. So those are the nozzles you can use with the Olsson block, and it's pretty simple. I mean, it doesn't take any time at all, and it just expands your capability of the printer and makes a huge difference. As you can see, another thing I changed, it's been about 6 months, and there's nothing mechanically broken about this printer. I mean, it's exactly as it came out of the factory. I changed absolutely nothing except one thing, and that is this guy, this white color thing. That is the nylon coupler. Now, over time, if you're using your printer a lot, it depends upon how many hours your printer has on it. I mean, it depends. It entirely depends upon that. So, if you don't use it that much, and if you just have it lying around for 2 years, then you have to replace this guy, because it will survive quite a lot. It also depends upon the temperatures. So if you're constantly printing in ABS like me, my printer is always running at like 250, 260. Even PLA, I run PLA pretty hot. And the reason I was printing PLA so hot is I'll come to when I talk about the feeder. But this nylon coupler, after, in my experience, about like 5 months, 4 months, you can see the performance degrading, and after the 5th and the 6th month, it's almost unusable in most cases. And I'll talk about the issues that happen with this nylon coupler. But you have to be, you have to have the spare parts for the nylon. I had this came with the hot end pack when I bought the Ultimaker. It came with in the box. Ultimaker provided a spare part, but apart from that, I highly suggest buy a couple of these, because they're pretty cheap. And it's always good to have a couple of spares, in case any day, if you're doing an important print, and if this guy, you can notice those problems, then it's a very simple fix. You can just put a new one, and it's almost running brand new again. So that's the only thing in this entire printer that I've changed over these 6 months of ownership. Another cool feature I want to show you guys about this new fan shroud is that the fans, they don't have screws, so I can just take them off like that, and that's it. This was 3D printed. I printed this in PLA. I used to have this same exact shroud in ABS, and it was working beautifully. But then I thought, why not try it in PLA? The reason I was scared of trying in PLA is, if we go on the bottom, you can see the nozzle. What I meant is why I wasn't scared in printing in PLA, because as you can see, there's a lot of space around the nozzle. So I really didn't think that temperatures would melt the surroundings that much, and PLA should work just fine. And honestly, I've had this shroud for almost a month now, and there is no melting, none of that. PLA has a very low glass transition, but considering all of that, it still is going without any deformation. So that's pretty amazing. I think that's the fan, the hot end. I don't think I have anything else to talk about. Yes, I also changed another thing is that when I changed my feeder, which I'll talk about, I also put a new board and tube. This is a low friction board and tube. It came directly from the guys at 3D Solex. They said this is a better board and tube, so I bought it. I haven't noticed any noticeable differences, but it is in just feel it is quite different. But that's just the another upgrade I made to the Ultimaker. I just add a new board and tube. But apart from that, everything is completely stock. The fans are exactly the same how they were. I haven't changed anything except the nylon coupler and the board and tube. So now let's go to the back and talk about the biggest change I made, which has made my job incredibly easy. Okay, so now we're at the back of the Ultimaker, and as you can see, if you know anything about the Ultimaker, is that this is a new feeder. This is a completely new, different feeder for the Ultimaker. And why do I need this feeder is just because of that. The thing that I did right now, this completely released the tension of the feeder, and now I can completely remove this filament. Now obviously it's stuck to the hot end because it's cold, but but this is the coolest feature ever, because now with this feature, there are just so many possibilities that I've opened up. For example, if you're printing in NinjaFlex, the biggest problem with NinjaFlex was that it used to curl up around this, and it was completely stuck. And removing that, that mess was a mess in itself. It was a huge pain in the ass. But now with this, you can just completely release the tension, and then you can just it just comes off. It's as simple as that. And this is the only reason I shifted to this feeder. This is called the robot feeder, by the way, and I'll put a link in the description if you want to download this and print it out for your Ultimaker. But this feeder makes a huge difference. I mean, for the longest I completely avoided adding this feeder, because I was just scared. I thought my feeder works just fine, but as soon as I started printing in exotic filaments, I noticed that the old feeder was just not cutting it, and with the new feeder, it just makes a huge difference. So I highly recommend you if you have an Ultimaker, this is the biggest and the most important upgrade I recommend. Now I'm using completely aftermarket parts. I'm not using any parts from the stock feeder. I'm using new springs. These springs I bought from AliExpress, I think. Then these these nut and bolts are the only thing I'm using from the stock feeder, but I'm using my own ball bearing. I'm using my own screws and stuff. Everything is according to my specification. The tension, getting the tension right is the most important thing with the robot feeder. It will be one of the best feeders in the world if you get the tension right, or it will be one of the worst feeders in the world if you get it wrong. So you need to be very careful with the tension. If you put this and if you're noticing that the results are not good, don't be scared. Just adjust the tension. The tension makes a huge difference. If it's too tight, it will come back. If it's not tight, it will grind. It has to be that ideal amount of tension in which it will it will not make the clicking noise, but at the same time it will not grind as well. So getting that right, it took me almost 2 weeks, but I was able to figure it out, and now it's exactly how I want it to be. And it's beautiful. It's absolutely amazing. I also have this yoke. This yoke is basically a yoke which just shortens the open space. That means if you're using a flexible filament, there is no space for it to curl up around the motor right here. So that's another cool bonus, you can say. So let me just open that up for you guys. I'll just switch on my printer. That's the relay clicking in for the battery power right there. So let me just turn it on, and you should have the lights. Oh, okay, not now. Okay, so now as you can see, we are at the front. Let's go to maintenance, advanced, move material. So now the nozzle will heat up to 250C, and then we can take a look at the feeder. So before I go to that, this is the one of the best upgrades I can recommend for the Ultimaker 2. It really makes a huge difference. Now until it, let's wait till it heats up. But before that, let's talk about the biggest challenge of adding the robot feeder, which I noticed when I installed mine. The thing about the robot feeder is that this part, this is called the, I don't know, let me just zoom in. This arm, as you can see, this arm, getting the screw lined up to this, there's a nut inside. So you have the screw, you have the screw, the spring, 2 washers, 1 nut, and the ball bearing. This is a complete assembly, and then we have the screws and washers for the ball bearing as well. This is threaded to the plastic, but there is a nut inside. Thing is, when you're pushing the spring to attach to the nut gets pushed upwards, and because of that, the screw never catches up with the nut. And that's a huge problem, because if it doesn't catch up, the system will not work. So you just have to add a dab of cyanoacrylate inside that space. Make sure it doesn't go inside the threads, otherwise it will not screw in, but just a dab. Keep that nut in place so you can thread in the screws and they'll make a proper connection. Thing about that is that after you try it once with ABS or PLA, the plastic wears out so much, because the nut, you have to completely hammer it in, that once it loses traction, it will just come up, and you just have to print a new part again. So get it right the first time, and you'll save a lot of trouble. So apart from that, everything went completely smooth. I mean, this assembling it's quite easy. I mean, there are no instructions online, but it's quite self-explanatory, I think. Okay, we are at 250C. So now let me show you what I'm talking about. I'm using the motors at the back, using the front, the wheel, the jog dial. As you can see, it works just fine. Now let's say the jog dial breaks, or something happens, or you just want to remove it as quickly as possible. You can just release the tension, which is the biggest feature of this block. Is that now what I can do is I can remove the tension. It comes off, and I can just pull it. Now this is PLA. It just broke, as you can see, halfway in. So that's the biggest disadvantage of PLA. It's so brittle that it just breaks. But you get the point. It's the point that matters. So the lack of tension that you generate by just unclicking this is just amazing. It makes the job so much easier. I also added this this filament guide. It's not really recommended. At first with the stock with the original feeder, I had this on and I noticed no improvements. But the robot feeder, the straight motion is quite important, because again, this is all 3D printed, so it's not exactly as stable as an injection molded part, but at the same time it is quite stable. It's stable enough that you can get absolutely amazing results. So when you keep that straight motion intact, this will be so quiet that you'll not believe that this part is 3D printed. Without this, I can notice some squeaks and stuff, but with this, it's completely dead silent, and that just makes a huge difference. I highly recommend adding this. It just attaches to a screw right there, and it's completely worth it. It just makes a huge difference to the entire dynamic of 3D printing. So this is one of my favorite features of the new Ultimaker. It just makes a huge difference. So now let's go to the next thing. Okay, so for the final thing I want to talk about is the heater cartridge right there. You can upgrade this stock heater cartridge to 40 or 30, 35. Yeah, the stock is 25, so you can upgrade to 35 as well as 40 watts if you just want to overkill everything. So that really makes a huge difference, because with the Olsson block, it's the mass of the block itself is so high that the 25 watt stock cartridge has a hard time heating it up that easily. So I mean, you'll not notice any noticeable or significant changes in heat up time. It'll just be that the fan you cannot run at 100% because you'll have a thermodynamic problem. So your fan will be cooling the block in the initial layers, because the air is getting pushed upwards because of the build plate, and it'll completely try to cool the block, and you will lose temperatures by by easily by 10 degrees in a matter of like 30 seconds, and that can result in heater errors. So that is the biggest problem with the block. It cannot compensate the air that is trying to cool it up. But with a 35 or even a 40 watt heater, this problem will be completely solved, and you can run the fans at 100% no problem without any issues, and you don't have to worry about waiting a few layers until you turn the fans on. And again, if you're doing a very let's say very small prints in which detail is very important, and you want to cool everything up as quick as possible, you will be limited by the stock cartridge, because even when you want to use fans, you cannot use them because of the heater error. So that is the biggest upgrade I recommend. My cartridge, I still haven't upgraded that, but I do intend to go to a 40 watt heater. Just it's overkill, but it's fine. I think it's worth it. So that is the thing I absolutely recommend, because it will make a huge difference in print quality. Another thing I would recommend is just oiling your XY axis, because over time, you just need to oil them. Do not grease them up. Only the Z axis will require the grease, because if you grease the XY axis, then you're completely fucked. So only grease the Z axis and keep the XY with oil. Anyway, that's pretty much it for the heater right there. So if you guys remember in the beginning of the video, I talked about this guy, the nylon coupler, and the problems you can face if it's broken or if it's about to die. So let me show you an example of what I'm talking about. So here is a print. These are the top layers of a print with the nylon coupler broken. I'm using 100% infill. It's not like 10% or 20% infill in which you have a perimeter issue, but this is a 100% infill print, and as you can clearly notice, the fill is completely messed up. That's pretty bad. It doesn't look that good, and that's because of the coupler. When the coupler is about to die, you'll have filling issues because it's not feeding it right, and the coupler is dead. The problem people will tell you is that the belts at the back, this guy, there is a tension issue with the short belts. That's not the problem. The problem is the nylon coupler. So over time, when you notice such artifacts in your prints, it's the coupler. Just change the coupler and everything should be just beautiful. So that's the last thing I just wanted to say. Apart from that, you shouldn't have any problems with this with these printers. They're pretty bulletproof. So that's pretty much it. These upgrades, they have really made a huge difference in printing. The overall experience has been amazing with all kinds of filaments, flexible as well as the normal thermoplastics. The feeder itself, it makes it's a big upgrade. I think it's better than the feeder used in the Ultimaker 2 Plus. That feeder is just amazing. Even the Olsson block, it's just a must-have upgrade. The biggest upgrade I'm looking forward to is the heater cartridge, and after that, I think it should be it. This should be the best performance you can probably get from a prosumer printer, under $3,000 or $4,000. It really is that good. So overall, these upgrades are highly recommended, and I think everyone should do this if you have an Ultimaker too. So that's pretty much it. I hope you guys liked it. Take it easy, and we'll be back with more 3D printing, more cool videos about 3D printing, in the future. So anyway, take it easy, and like always, have a good one. All right.
see me flipping scripts, acting all wild and reckless. Never skipped on the beat drops and mic check flexing. Wrecking secondhand styles, loops and breaks. God bless if you're getting it now. It's better to be late than to never ever get with the vibe and one love.